that's not the first exercise. Take a look. It says a stone is thrown from a bridge. I'm obsessed with bridges, I know. I'm sorry about it. I could have used golf exercises, but golf is boring for me. I like bridges a lot more. So a stone is thrown from a bridge at an angle of 30 degrees with the horizontal in the downward direction, with a speed of 25 meters over second. If the stone strikes the water after 2.5 seconds, then calculate the height of the bridge from the water surface. As you can see, this exercise is slightly different because projectile motion, sorry, there are many options, okay, to include for projectile motion. So this is another kind of example. So let me show you how to work with this kind of exercise. First, I'm not giving you a sketch, okay? I'm not giving you a sketch, so you will need to work on that. It doesn't need to be the most beautiful sketch in the world, but it should fit your needs, okay? So, I was starting to draw it, and I said, I'm going to use an old picture. And then I said, no, I'm going to teach these kids how to draw. Because, well, in physics, not all the time, I'm going to be giving you the sketch. So the only idea for a bridge that I had plenty of ideas, but this is the most common. But I don't know. That's great. Okay. And this person is right here. I'm gonna do it in blue. And for some reason, that person is happy. This is Monday morning. That's why he's happy. Okay. You know, everyone's happy on a Monday morning. So it's about a stone. Okay. There you go. I have the stone right there. So the problem is telling you that he's throwing the stone at an angle of 30 with the horizontal. So, remember, I'm going to draw my angle. This is my x-axis, and this is my y-axis. Okay? So it says that it's being thrown at an angle of 30 degrees. So the direction that this is going to have is going to be more or less like that. And of course, I will include my angle of 30 degrees. Now, they're asking me, it says that the stone is at a velocity of 25 meters over second, and I want to know what is the height of my bridge. Okay, that's what the problem is telling you about. It says, okay, what's the height? So I need to find its height. I know that in this point I'm gonna have my river. Okay, and a fish over there to make it more realistic. I'm such an artist. Sorry about this. This time it wasn't my cat. So that's it. That's all we have, and also the time. But the time you probably don't want to put it in the sketch because you don't see the time. Okay. Now the what we do is we list the givens. That's always the mandatory step. Even if you already have the givens in the sketch, it's good that you have it apart. Okay. So in my givens, I have the angle that is 30 degrees. It says with the horizontal in the downward direction. So it says downward from horizontal. The horizontal axis is the x-axis. Okay. Then it says initial speed 25 meters over second. It says the time is 2.5 seconds. And what else? And they're asking me to find the height of the bridge. If I want to find the height of the bridge, I'm looking for the vertical change in position or the horizontal change in position.
Vertical.
Vertical, okay? So I'm looking for the height, and it refers to a vertical dimension, a vertical measurement, okay? So in other words, I'm looking for the delta y, okay? What is going to be my change in position vertically? That's everything the problem is giving us, but you know that we can also include gravity. Okay, acceleration due gravity, that is negative 9.81 meters over second to the second power. So this is what we need to look for. Delta y is the unknown. Okay, that's like the most important thing. So let's take a look to the equations. Remember that I told you that there is always a mandatory step that we call it the first step. What's the first step?
Find the components.
Find the components. The components, okay? In x, but also in y. Okay? So that will be the first step. We're going to be calculating the components. So as a first step, that's what we're going to be doing. First step, components. Okay, so I'm going to get my x and y components. My initial component in x is going to be equal to the initial velocity, cosine of my angle, and the initial component in y is going to be initial velocity, sine of my angle. I replaced but the information it was given in the problem, so this is going to be 25 cosine of 30 degrees and 25 sine of 30 degrees. How much do you get in the first one?
21.65.
1.65.
21.65 meters over second. Now, where is the stone going? Is it going to the right or going to the left?
To the right.
Right.
It's going to the right, so it's going to be positive because it's going to the right. In y, how much did you get? 25.
12.5.
Meters over second. 12.5 or 50 meters over second. Now, how is the stone moving? Is it moving
Down.
It's moving down, so it's going to be negative and negative over there. That's the first mandatory step. Then we're going to see what we have and what we need to get the delta y. Okay, so I'm looking for delta y, so I'm going to look for an equation that works to find delta y. What equation works best to find delta y? According to all these equations I gave you. The one that says delta y. It's already isolated for it, okay? We don't need to even do another isolation because it is already there. So the equation to find delta y is already given. Now let's see if we have everything we need to get it, okay?
Yes.
It says initial velocity in y. I already have it. Somebody say something. Were you asking something? because I was seeing the iPad that I couldn't listen. So if you ask something, let me know. I have my initial velocity in y. I have my time. The time is repeated, so I have two givens over there. And the gravity is also given, so it means that I can use the delta y formula. So I'm going to just do my second step. This is a short problem. So I'm going to find delta y, and the equation for delta y is delta y equals initial velocity in y times delta t plus 0.5 gravity times delta t raised to the second power. Now we plug in the givens and we say delta y is equal to initial velocity in y gave us, is this one right here, it gave us negative 12.5. The time is given in the problem and is 2.5 seconds plus 0.5 from the formula, gravity, which is negative 9.81 meters over second squared, and then it says delta t raised to the second power, 2.5 seconds to the second power. How much do you get from this multiplication?
61.91.
How much?
Negative 31.25.
Yes, that's what I got. Check again.
I think Sarah was talking about the whole answer. Yeah, equation.
Okay. Is that I do it in parts. I do it in parts to avoid mistakes. Okay. So only from this part I got negative 31.25. Take a look here. I cancel these seconds with the seconds from the time. So my remaining unit will be just meters. Okay. Now, this answer here is going to give me also negative because I have positive, negative, and positive is going to give me negative. Okay. So I'm going to leave the negative here. Or it doesn't, I don't need, okay,
It's 30.66.
Okay, from this, we got
Negative 30.66.
negative 30.66. And the units are, take a look, these seconds are raised to the second power, so they are second square. These second square are going to be cancelled with this second square, so the remaining unit will be just meters. And now, in the last part, you could just perform the addition of the two negatives. It's going to give you a negative answer. Negative
Negative 61.91
meters. Okay, now we need to analyze this answer, okay? Because you cannot say that a bridge has a height of negative 61.91 meters. That would be incorrect unless the bridge is underground, okay? So what we can say is that the negative indicates, that's just the analysis, okay? In the end, you're just going to write a sentence. So you can just write that the negative means that the stone ends in a lower position and I missed the S, ends in a lower position from which it was thrown. That's what the negative means. That's what the negative means, okay? But we are not answering the question. The question says, well, or the instruction is, calculate the height of the bridge from the water surface. So remember what we do. We put a reference, okay? A reference position. So we say that the place at which the stone is being thrown could be the initial position or the origin of the problem. And we can say that that position is 0, 0. Okay? We can say that that position is 0, 0. It's not a surprise face or surprise emoji, that is a position 0, 0. And the stone ends right here. At what position? At a final position of negative 61.91. Okay? That's what you can say about it. Okay, now you can see. You can say that the final position will be negative 61.91 meters. But in the end, what is the height? The height is just a number, a difference, okay? A difference. So the height will be, you just write it in a sentence. I mean, there's no way that you can get it in, they get a formula for that. You have to get it in after the analysis as a sentence. So you can say, therefore, okay? I don't know if you know, but those 3 points located like this means therefore, okay? I'm gonna write the meaning here. Therefore, the height of the bridge, or the bridge's height, is 61.91 meters. Here, as you can see, it's positive. Because when you talk about measurements, measurements are always positive. Okay? Emma?
If I have a question, when you did the sketch, you draw the angle on the first quadrant.
Yes?
It has to be up next or because before we did it down next, but in this case it's up.
No, it's below.
Oh, yeah, because I see that X, the red line, I think that it's like X
No,
axis.
take a look. Because the way I draw the sketch, as you can see, it is kind of like inclined. Um, so I say that this parallel line represents my X position, and this vertical line represents my Y position. So the stone is being thrown at this angle, at an angle of 30 from the horizontal. It says downward direction, so it means that is below the horizontal. That is because of the sketch. If you want me to draw it better, I can do it better.
No, it's okay.
It
That
was
was
my
just like
best. I promise
confusing.
it was my best. In the other hand, what you can do is just drawing the vector. That's what other people do. They draw the vector. They know that the initial velocity is 25. So they say, and it says 30 degrees with the horizontal downward. So they say, okay, it's, what they do is this one. Okay, they name the vector as velocity 25 meters over second, and then they put the components. Bx and By. And to indicate that this is the angle, let's put the angle here, 30 degrees below the horizontal. That also works. To get the components, that also works. Because here you see that the component in x, it goes in the positive direction, and in y, it goes in the negative direction. So both ways are a good way to sketch the problem. You can use the two of them, because I know that it looks very messy in the beginning. So you can do a general sketch, to represent all the situation, but then you can take the vector apart, like I did right here, and have like a better perspective how the vector is going. That also helps, okay? I'm not saying it's mandatory to do it, but also it's very useful. So I totally recommend to do it. So as you can see, it was only a two-step problem. It was more difficult the drawing than the procedure itself. So that's it. That will be it for this kind of topic. Okay, remember this is projectile motion at an angle. I'm going to write it here since I can forget. At an angle. Okay. Now this is, yes, I'm gonna move it again. This is projectile motion, horizontal projectile motion. Okay. Now take a look to this exercise. I love it because I love cats. The most beautiful and perfectly created cat chases an evil mouse across a 1.5 meters high table. The evil mouse steps out of the way, and the cat slides off the table and strikes the floor 2.65 meters from the edge of the table. When the cat slid off the table, what was its speed? So we need to find the cat's speed at the moment it leaves off the table. I lost. Ah, no, aquí lo tengo. I am dumb. Sorry. So, I consider this topic to be the easiest of them, okay? Because, I don't know, I find it very, very easy, okay? So, what I have in this problem, they're giving me that the table measures or has a dimension in the vertical axis that is 1.5 meters high. Okay, so you must indicate the height right here, 1.5 meters. Remember that when we talk about height, we're talking about vertical position. So basically, this is the delta y for this problem. Okay, so the cat is chasing the mouse. Okay, so the mouse steps away, and the cat, what he does is flies off the table. So the trace that the cat probably follows is this one right here. Okay, this is more or less to represent the path that the cat follows when he slides off the table. Okay, so it says the cat slides off the table and strikes the floor to 0.65 meters from the edge of the table. So measured from the edge of the table, from this very edge, okay, so from the edge of the table, like that, more or less, queda un poquito feo, wait, no era eso, pero bueno. Fine, more or less, okay, so it says strikes the floor 2.65 meters from the edge of the table. So basically, they are giving you in that point, they are giving you the delta x. I mean the change in the horizontal position from the point at which the cat slits off the table and strikes the ground. Okay? So it's measured like this, horizontally, like that. So basically this is delta x and this is 2.65 meters. And they're asking you to find the speed at which it leads off the table. So I need to find my initial speed. Okay, this is going to be my unknown. My initial speed or my initial velocity is going to be my unknown. So from this, I write down the givens. I know that the givens are like too obvious. It's just delta x and it's just delta y. And its gravity, of course, negative 9.81 meters over second squared. Okay, it's not updating. Amazing. Wait a second, guys. Okay, so that's it. That's everything you have about the given. What we need to find? We need to find VI. Now, what is the step that we do to find the VI? I mean, what's the missing given that is mandatory to get in order to find the initial velocity?
Find the time.
To find the time. That will be the first step. Okay, will be find the time. T or delta T? You're more familiar to delta T because of myself. Okay. I'm guilty. So the formula for delta T for this kind of problems is delta T is equal to the square root of, remember this delta T formula comes from free fall, okay? Twice delta Y divided by the gravity. Now, take a look about the delta Y. I just put delta Y 1.5 meters, but it's actually not like that. So I'm going to change it because it's different. This is just the height of the table. Now take a look what I do with delta Y. Delta Y, remember, is equal to the final position minus the initial position. So my initial position is in this point. We call this point 0, 0. That is the initial position, okay? And the final point is right here. And, well, I don't know about you, but it is 1.5 meters below, which means that in Y is negative 1.5 meters. And in X, it's going to be plus 2.65. So in x it doesn't change, but in y, remember it changes. Why? Because the final position of the object is below the initial position. So in that case, always the delta y will be negative. Remember this. When the object's final position is below the initial, delta y is directly negative. But you can get the delta y with the formula x final, which is negative 1.5 meters. Minus initial, that is 0. So in the end, delta y is negative 1.5 meters. Now I do it apart. I always do it apart. I do it for teaching purposes. In the end, I never do it like this. Remember this. The negative means that the object final position is below. Final vertical position is below the initial position. Guys, I always write it. I always write this, okay? So keep that in mind. How much do you get with delta t?
The whole answer.
Yes?
Or what is inside the
0.55 seconds.
0.60.
55.
0.55 seconds.
Did you get the square root?
Yes, with the square without the square root is 0.
0.40.
I got 0.55.
Without the square root is 0.31. Without.
With the square root.
Yeah, sorry, with the square root.
And then delta t
30. 30 means
30. Sorry.
0.31.
0.31.
Yeah.
And then the square root of this answer is... Okay, after you get the time as 0.55 seconds, you go for the second step, which is finding the initial velocity. Remember that to find the initial velocity is in the x-axis. The reason is that, sorry about this, in this point the object is not, the cat is not moving vertically, he is just moving horizontally, okay, only moving in the x-axis. That's why here the initial velocity is just in the x-axis. So let's apply the formula to find the initial velocity. Find VI. There is a concept in this kind of motion that says that the initial velocity in x is equal to the initial velocity to the final velocity in x2, okay? So that means that the velocity in x is constant. Remember that concept, it's constant. So initial velocity in x is equal to, according to the formula I gave you, is delta x divided by delta t. Apply the formula, plug in the givens, and you will have 2.65 meters divided by 0.55 seconds. So the initial velocity in x is equal to 2.65 divided by 0.55, and it is 4.82 meters over second. That will be the final answer.